Here we are given the rate of increase of number of married couples from year 1970 to 2005, and we have to find the model using this information. That is, in 2005 the number of married couples is 59,525, and in part B we have to predict the number of married couples in 2008. So let's start to do this. Basically, to find the model we have to find the integration. That is, we have to integrate this derivative function, which is dm by dt. So let's do that. Let me copy the dm by dt over here. Dm by dt is given as 1.218 t square minus 44.72 t plus 709.1. So this is basically the derivative function, and we know that when we integrate the derivative function we actually get back the original function. So let me do the integration on both sides. So I put the integration symbol with dt. In fact, I could also put the dt over here. So on the left side, when you integrate a derivative function, we basically get the original function, so which we can represent it as m of t. Now we can integrate this into several parts. We have three terms inside the integral. So let me write down this as 1.218 t squared dt integration minus 44.72 t dt. This is for the second term. And for the third term, I have 709.1 integration dt. So now we can apply the power rule of integration. In fact, we can also factor out the constants uh, so that we can integrate only the terms with the variable t. So when I do that, I will be getting 1.218 integration of t squared dt minus 44.72 integration of t dt plus 709.1 integration of dt, or just 1 dt. Now let's apply the power rule. So when we apply the power rule, we must be knowing that integration of x power n dx, this is equal to x power n plus 1 divided by n plus 1 plus integration constant, and n should not be equal to -1. So we'll utilize this formula to integrate this. So let's start to do it. I put the constant 1.18 and apply the power rule, that is for the t square. Here we have the exponent to 2, so we just have to add the power 1 for the power 2, which we do like this: 2 plus 1 divided by 2 plus 1 minus of the next term is 44.72. We have integration of t, which is basically integration of t power 1. So we put a t power 1 plus 1 by 1 plus 1 plus 709.1. Integration of 1 dt is basically a t. And we also put the integration constant, that is the c. Now let's continue. We will get this simplified. So therefore this is equal to 1.218 t cube by 3 minus 44.72 t squared divided by 2 plus 709.1 t plus the constant c. So we can further simplify this as well. That is, we can reduce this fraction by cancelling out these terms. So when I cancel it like this will be 0.406. I put down here 0.406 t cube, and similarly I can cancel this 44.72, and it comes out to be 22.36. That is, I basically divide by this denominator, and then we have this t squared plus this term remains the same, 709.1 t plus the constant of integration. So basically this represents the m of t, but we are not yet done. We have to determine the value of c. So for that we will utilize the another information which is given in this question, that is, in year 2005 the number of married couples is 59,525. So let me put it over here. In year 2005 it is 59,525. Which means we have to convert this year into the number of years since 1970, because we know that t equal to 0 or the year 1970 is represented by t equal to 0. So we have to find the corresponding t for the year 2005, which means we have to subtract or we have to calculate the number of years from 1970 to 2005. So this basically, when you do the subtraction, we'll be getting 35. So therefore, this is the t value that we have found out. That is in t equal to 35, the population is 59,525. So I'm going to plug that into this equation so that we will get the value of c. So I'm going to plug in. We have 59,525. I plug in for m of t. This is equal to, and I replace all the t by the year that we have found, that is 35. So I can do it like this: 0.046. 35 is to the power of 3 minus 22.36 35 square plus 709.1 times of 35 plus the constant of integration. So we can plug this into the calculator, so we can find this value. We can find this value as well as this value, add them and subtract them together, and then finally we have to subtract that value from 59,525 and then solve for c. When we do that, we get the value of c as 44,690. So this is the value of c, which means we can write down the model as like this. So let me clear this up. Let me plug this value of c into the model. So therefore m of t becomes, the complete model is 0.406 t cube minus 22.36 t square plus 709.1 t plus 44,690. So this is the complete model which represents the number of married couples since the year 1970, which means we answered the question in part A. Let's now do the part B. In part B, we have to predict the number of married couples in 2018. So we have to first convert this corresponding t value for 2018. So we can subtract like this: 2018 minus 1970. So this will be exactly 48 years. So therefore, we just have to plug in t equal to 48 into our model and find the number of married couples. So let's do that. So I'm going to plug in t equal to 48 into the model. So therefore this becomes m of 48 is equal to 0.406 48 cube minus 22.36 48 square plus 709.1. In fact, it is 709.1 times of 48 plus 44,690. So we can just plug all this into the calculator and determine the value, and this comes out around 72,110. So this is the number of married couples in the year 2018. So we have found out the model as well as we have calculated the number of married couples in year 2018.